Okay, we'll just give it a couple of minutes for people to join, and then we'll get started. Okay, I think we might as well jump into it. So, welcome to today's live stream. Today we'll be talking a little bit about LoRaWAN, the Things Network, and how you can set up your LoPy as a Nano-Gateway. I'm going to be looking at setting up two LoPys, one to act as the gateway connecting up to the Things Network and being able to transmit your data forward your packets up to the internet, be able to then retrieve them and do other online applications with your data. So this could be putting your data into a database, it could be retrieving your data and displaying it on a website, it could be having your data act as a trigger to interact with another action or activity. There's a whole range of things you can do once your data hits the internet. But the thing that we're interested in today is getting your data from your LoPy over LoRa to the Things Network and then back to your application. So I mentioned about the Things Network. I'll do a quick overview of what that is and why it might be interesting to you. So let's see if we can jump over to that. So let's have a look at Chrome. So the Things Network is an open source, open community distributed network for LoRa, or LoRaWAN. What this means is people who want to interact and contribute to the network can deploy their own gateways, their own effectively base stations, and create community hubs for IoT devices and connected objects. There's no subscription model for this at the moment. There's a free interactivity, so you sign up, you register your applications, and then anytime your device goes into range of a TTN network, you'll be able to interact with any of your applications. So right now we're based in Guildford, and we have coverage from our own gateway, and also we're going to show you how to set up your own Nano-Gateways to use as your own deployments. So the use case for this might be you're in a town or village that doesn't have TTN coverage, but you want to start interacting with your LoPy and start collecting data over the Things Network. So we're going to show you how to use the LoPy as a Nano-Gateway and be able to connect via TTN without having to purchase a fully fledged, very expensive multi-tech or another model gateway. Basically, the idea with this is we can use this platform to do prototyping and test up to 100 devices, other LoPys on your network. So the Things Network is a really nice platform because it lets you quite easily set up gateways and applications. So if we jump in quickly, we can see the console. And again, some of this data might already be up and generated from what I've been testing, but just to ignore most of these cases as we're going to create some from scratch. So once you've signed up and registered for TTN, you'll have two application sets that we're going to need to set up today. So we've got applications and gateways. Gateways are the connection between LoRaWAN and the internet. So these do all of the packet forwarding to your servers, to your databases, to whatever application or space you're trying to operate within. Your applications are your specific data sources. So here you can specify which of your fleet of LoPys, for example, do dumping into a database or do packet forwarding to another server, or you specify the endpoints of where you want your data to go through the application panel. So if we quickly jump into the applications, I'll show you some of the things that I've set up. So we've got two on here right now. So Pycom Office is the application I'm using for monitoring the moisture levels in some of the office plants we have around the Guildford office. And what that does is you can see some of the information. So we've got two devices that are currently set up with this application. What it does is it sets up with some integrations. So in this case, I've taken this off, but we can go through create an integration, and you can see there's 4 main tabs that you can use. So you can use data storage, HTTP integration, which is packet forwarding. So once your data is received by the Things network, you can then send it on to other networks or other applications using the Things network integration. Or you can also use IFTTT, which is, if you're in the Maker community, you'll be aware that you can do a lot of really interesting integrations with other platforms, things like Slack, Dropbox. Lots and lots of different organizations get involved with IFTTT to basically allow you to connect various different products up to one another. So for example, what you could do is you could take your LoPy, have it set up so that when its data is received by the Things network, it then forwards that data onto IFTTT, and then that sends a message to maybe Slack or send you a text message or an email to update you about your information. So there's a number of different integrations you can use and a number of different things you can do with your data. Let's see if there's any data that's come through in here. Okay, so this is from earlier today, I believe. So you can see this is some of the data that's been received by the specific application. This hasn't gone anywhere, this has just been received. And you can find out a little bit more about the data. So in this case, just looking at some of the payloads. So these were, let's have a look for uplink only. Yep. So this had a payload of this specific data set. I believe I have that currently encoded for some of the moisture levels, or it's basically an analog input, and then it's between a certain range, and some of that range is mapped to those values, and then also I believe there's a little header telling me the battery life of the device as well. So you can kind of see where I'm going here with what you can do with the Things network and how you connect up your different devices. We'll set up an application once we've got a gateway up and running, and I'm now going to show you that aspect of the Things network. So we've got a couple gateways here. We have a fully fledged gateway, which we're using for doing the deployment across Guildford. So this is our fully fledged, many kilometer ranged gateway, which is spanning across Guildford and providing coverage for anybody who wants to connect up using TTN. And then we also have a couple of these Nano-Gateways, which we're using for just prototyping and testing. And what the real advantage of Daniel's code and the code that he wrote for the Nano-Gateway is to really allow you to start getting access to networks like the Things network to start doing deployments, because fully fledged gateways are actually quite expensive. If you want to purchase a multi-tech gateway, you're looking at 400, 500 pounds worth of kit, and that's not always feasible for someone who wants to prototype or test out ideas. So to be able to do it with one LoPy as the gateway and then have others connecting to it, you're looking at a cost overhead of a fifth, sixth of the price, which is significantly easier for a maker to take on board. So let's have a look at our gateway and how that's connected up. So I believe this one's connected to the network. Yeah, so this is one I have already. I can grab it, yeah. If I grab it, I'll just disconnect it quickly and it'll come back online again later. So we have our LoPy. Let me jump into my overhead camera. So this is the device we're going to be using later to program as a node, and this is the gateway that I'm currently using. So it's your standard LoPy. It's just in a Pi case with expansion board. This plugs in via USB, just powering it. You can power it however you want. If you wanted to power it via battery, you could do that. And then I just have it sitting on mains so that we have a secure connection, and it's connected back up to our office Wi-Fi, and then relays the packets from LoRa to our Wi-Fi. So I'm going to plug that back in quickly, and then we can start seeing how that's set up. Okay, so that should reconnect to the network again. You should eventually see it come online through this last scene tab. But yeah, you can set your gateway up and find out information about where it's located. So in this case, we've got it in Guildford. You can see on the map. And then you can view the traffic as well coming through the network. So right now, it's not doing anything because it's not online. We've just unplugged it. But later we'll be able to see when data starts coming through. So let's have a quick look at the code that Daniel released a couple of weeks ago and see how you can set up your own nodes as well. So if you head to github.com/pycom/pycom libraries, you'll find under examples there's a folder called LoRaWAN Nano-Gateway. And this specific gateway code is set up to work directly with TTN, and there's a couple of different configuration methods you can use. So if you're familiar with LoRaWAN, you'll know that you can do two types of connection to the network. So one is activation by personalization, which is a less secure method but easy for testing as you don't have to set up any keys. And then there's the over-the-air activation, which is a key exchange between two devices to ensure the authentication and originality of the data. So we're going to look quickly at some of his code and explain how it works, and then we're going to walk through the whole process of setting up your own gateway and getting it on the network. Okay, so there's quite a few libraries that you involved with this, and basically the way that it works is the LoPy boots up into its main.py script and then calls this class, which is the Nano-Gateway.py class. And it does get quite complicated, so I'm going to keep this fairly brief and just explain what's going on the gateway side of things. So what we need to do with the gateway is we need to take the incoming LoRa data, which is in the LoRaWAN specification, and then convert that into an HTTP packet and be able to send it back up to TTN. So that's what we're doing over Wi-Fi, and this is what Daniel's code is doing. So we have an initialization function, which takes in various parameters that you can specify in the config.py file. These are all set upon initialization. Then the gateway starts up. It then connects to the Wi-Fi, sets its real-time clock, syncs that with the network so that the packets it's receiving are accurate to the time zone it's located in. So you need to set that to your region and wherever you're operating from. And then it starts a couple of these other functions to do with pushing and pulling data, and that's both receiving from the LoRa side of things and also sending data up to TTN via web requests. So you can see the gateway initializes its LoRa antenna, a LoRa radio, and then starts receiving data through its socket. And then it sets up a callback based upon receiving and transmitting data so that it can then relay that information back up to the network. We have a quick function here that just talks about stopping and shutting down the gateway. There's some thread-safe stuff that needs to be done, but right now it's fully functional. It's just some additional nice features that would help with any crashing or restarting if the gateway, if that were to occur. We've got our connect to Wi-Fi function, which is fairly straightforward. If you want to find out more about Wi-Fi and how that works, we've got some good docs that explain connecting to a network, looking for various SSIDs, but that's a little bit out of the scope of today's session, so we're going to look at a more overview of how that works. These specific functions are to do with the, I believe, the conversion of LoRaWAN packets. And then we have the actual crafting of the statistics packets for TTN. So this is when the data goes up to TTN and is received by their servers, which then can relay it to your various locations. So this is, for example, like crafting the packets for the node, pushing data, pulling data, and this is all basically acting as a relay between LoRa and TTN, or LoRaWAN between your LoPy and your gateway, and then TTN as well. So what happens is the device sits with a thread running in the background. When it receives data, depending on what type of message is sent to it, whether it's been authenticated, whether it's actually a device that's registered for that network. If it is, then it sends the data up. If it isn't, then it just rejects that data And it's also sitting waiting for data to come down from TTN. So for example, if a downlink message was configured, then obviously your gateway needs to know what to send it back to the node which is deployed in the field. So it's also doing that and grabbing the downlink data from TTN as well. And then here we have our thread, which is handling all of our alarms, all of our callbacks, and just generally checking to make sure that data is being relayed in the correct manner. 1 second. Okay, just move my child screen so I can view that as well if anyone has any questions. Again, feel free to stop me as I'm going along, ask your questions. If you save them to the end, it might not be so easy for me to track back to where you're asking a question, but if you do have them, feel free to ask. And yeah, so I think what we'll do now is we'll look at actually how to set up your own gateway. If you want to have a look at or have a further explanation into the code, feel free to create a post on the forum. And if there's something you're concerned about or something you want to know more about, just ping me a message over the forum, and I'll try my best to help you out there. So let's look at now getting a device actually onto the network. So I'm going to jump over into my code editor, Atom, and look at the configuration settings you'll need for your device. So let's just jump over. Okay, so here we are in Atom. So there's a number of files that are involved with setting up the LoPy Nano-Gateway. And these are config.py, main.py, your Nano-Gateway library, and then also your node code as well. So there needs to be the code written for the LoPy that's sending the data up to the gateway. So if we quickly jump into main, we'll see when the boot.py file starts upon boot up from power off to power on mode, then it runs the boot.py file, which in this case doesn't really matter what happens there. It just executes and then moves on to the main.py. So then we do an import from our config to grab all of our settings. We load up the Nano-Gateway library, and then we initialize an object with all of our config data. So here we're specifying gateway ID, LoRa frequency, data rates, the Wi-Fi SSID, Wi-Fi password, the server that we're sending data up to, in this case TTN, the port, the network clock so we can get accurate time, and then also the period of refresh for that as well. And then running our Nano-Gateway script. So that's fairly straightforward, but let's have a look at the config as well now. So the gateway ID, when we set up in TTN, it'll prompt you for a gateway ID. This is so that we can recognize which gateway is sending data, so that TTN knows where it's coming from. We then specify our server, which is where we want to send our data once we've received it in LoRa and send it back in HTTP. That'll go up to this address. You need to specify the port, the network time server, the refresh interval, our password. Obviously, in this case, it's not the Guildford Office Wi-Fi password, as we kind of need to keep that secret. So you'll use yours instead of your password blank here. The LoRaWAN frequency. So if you're based in the States, you'll use 912 megahertz. In this case, we're based in the UK, so we're using 868 megahertz. And then the data rate specifications. So once you've got those set up, that's basically it, other than uploading your code to your device. So however your preferred method of uploading code, I use FTP and normally use FileZilla to push my code. So what you'll do is you'll copy over, let me get FileZilla up and show you how that works. Let's see if I can remember the IP address of our device as well. So fire up FileZilla and upload the code to our device. So I believe we're using 101 connect. Let me check quickly. Yep, that's the right one. So I'll open that up quickly in the webcam. Okay. Perfect. Okay, so here we go. So let me scale that back a little bit, that's a bit too big. Okay, so you can see that we are in the file directory of the LoPy, and here's the flash storage. You've got your boot and main.py files, and then over here we've just got my my library of the code I've written ready to be transferred over. So what you'll do is inside your lib folder, you can just drag and drop your config. You can drag and drop your Nano-Gateway library, and we don't need that, so let's just get rid of that quickly. And that's it. So you just, in your lib folder, drop your config.py and your Nano-Gateway.py files back into Flash. Your boot.py doesn't need to have anything in it. Just make sure that it's not got any errors so that it executes correctly. And then drag and drop your main.py file, which was the startup script, effectively. And so once those have been uploaded to your device, you're ready to go. And we'll look then about how to set it up actually on TTN. So let me jump back into my web browser. Okay, so we're back in the web browser. Let's go back to gateways. We will register a new gateway. So let's call this, so this is the unique identifier that we got earlier. So this is basically just a string to identify your specific gateway. Let's just change a couple of these values. So this is just so that we can identify where they're coming from. It's nothing specific, doesn't need to be set up or generated by TTN. It's just an identifier. Give it a description. So let's call this Alex's Corner Week 3 demo. Give it a frequency plan. So again, depending on where you're located, it'll ask you information regarding your frequency regulations. We're in Europe, so we're going to give 868 MHz, and then specify the location of your gateway. So this should be the exact location, ideally, of where you've got it placed. For us, we're going to delete this in a minute, so it doesn't really matter. We'll just dump it in Guildford. So that's placed. And because we're using it indoors, we'll just set it to indoors. So we can now register that gateway. So fantastic. Our gateway has been registered on TTN, and now we just need to connect it up and get it running. So we don't actually need anything to do with this gateway key. This key is actually, you don't need it at all to do with the setup of the device. So ignore that. You can fill in information about your brand and model, but you won't be able to find the LoPy specifically on there, as it's not a true full gateway. It's a Nano-Gateway. And yeah, you can then declare it as public or private, depending on if you want to share it or if you want to keep it to maybe an office or a university environment, or however you're planning to deploy. And then you can also see your traffic by heading to the traffic tab and scrolling down to see uplink down. I can join messages. So we've got the gateway now registered. Now we just need to connect it up and get it going. So if I quickly jump back into my my Atom, and then we'll set the gateway ID the same as this. So if we copy quickly that gateway ID, go back to Atom, and change the gateway ID we have on here to the one I just created. Save that, and then I'm going to quickly jump away from here back to FileZilla. I'll enter just the information about network, SSID, and password. And obviously, you enter your own network SSID and password. Ours won't work for you because we have our own Wi-Fi network. And then once that's there, I will sync it with FileZilla, and we're ready to go. So just save the code. Should get a prompt from FileZilla in a second telling me I made a change. I know I've edited this locally. So if I go over to library now, and then I drag my updated config file, ask me if I want to overwrite it. Yes, I do. And fantastic. So that's now gone over. That's uploaded to the device. If I quickly go and reset the LoPy is acting as the gateway, so you can do this by pressing the reset button on it. That will now power cycle. And I'll grab a terminal prompt up so we can see exactly what it's doing. Okay, so let's jump into that. Oh no, it's not connected. I'll go find out actually. This is the difficult issue where I run out of USB ports again. Okay, well, we'll see the gateway appear on the network once it's been registered. So let's go back over to the browser. Let's have a look at gateways again. So that's not connected up just yet. Have we booted up properly yet? Should be. Might need to send some traffic data to it to get it to work. Let's have a look. Actually, let's just use the example I've already got set up because that way we can see where it connects to the network. Let's pop back into FileZilla quickly. Okay, let's connect up. So I'm just resetting gateway again to restart the main script and get the code running that we had up earlier. So let's go back gateways. We'll have a look at the lovely example that I prepared earlier. So that was last online 3 minutes ago. So hopefully that should be connected up now, and we should see it coming through. It might take a little bit of time for it to actually jump on the network. Otherwise, I'll connect it up and we'll look at the terminal prompt to see what's happening. Okay, let's plug it in. That's probably the easiest thing. Okay, so what I've got here, I've just got my my LoPy, the one we're using is Nano-Gateway. I'm going to plug it in, and we'll look at the terminal prompt for that to see what it's doing. So that's just been plugged back in again. I'll fire up terminal, and we'll jump into it. And then we'll give it a restart so we can see exactly what it's doing. Okay, so you can see it. Oh no, you will be able to see it in a second. Where's my terminal? Okay, so you can see that we booted up, Wi-Fi connected, and then it got all the way through the script, and now it's back at the Python REPL. The way that this works is because the device is actually using callbacks. So in the background there's a thread running which is monitoring for any activity that happens on the network, and you can see when it does pull acknowledge, push acknowledge, this is the callbacks that are triggering. And then if we go back over to, if we can move this out of the way, you can now see that actually the gateway was last seen online a minute ago, and should have been when it connected. It should now be sending acknowledgements backwards and forwards. So that's the gateway we have connected here, sending the acknowledgements. So assuming that your gateway connects to your network, sets up correctly, and there's no errors with any of the configuration settings you've set, then it will start pushing and pulling acknowledgements to and from the Things network. And you can see now actually when we do go back to TTN, you can see that last seen was, in this case, 24 seconds ago, or until it does its pull from the network. And that actually can be seen if we go over to our code. I believe it does every 60 seconds or so. Try and see if I can find that where it does that. It's somewhere in Daniel's code. I'll jump back into it at the end if we still have time. So we've got our gateway online now, and this is our hub for receiving all of our data and then relaying it back up again. Now what we want to do is we want to create a node. So a node that can be configured to connect to TTN, use our Nano-Gateway as a relay point, and send our data back up again to TTN. So if we jump back over into Atom, we'll have a look at the code required for doing the LoPy node. So let's have a look at Atom again. Right, so here we are. We've got our over-the-air activation. So you could use OTAA, which is over-the-air activation, or you can also use activation by personalization. Most secure connections use over-the-air activation, so we're going to use this one because this is the most likely use case that you'll actually deploy. And we'll have a look at some of the setup and settings for this. So this is slightly different to the examples that we have on the documentation. This is because you need to set something specific to TTN so that that information is matching. Let's walk through the code. So first of all, from the library, from the network library, we're importing LoRa, then importing sockets for doing the connections, bin ASCII, which is doing the hexadecimal conversions or replacements, struct, which is to do with some of our data structures, and then time, which is to do with just sending an interval of data, an interval of various payloads so that we can actually see that it's doing something. Then we do our LoRa constructor, which creates our LoRa objects from the LoRa class. Then we're setting up our device EUI, and that's set back over in TTN, back in our application. We then set up our application EUI, again back in TTN that's set up, and then also our application key. So the key is required to do a handshake with the network to make sure that the application that it's sending data to is configured correctly, and we'll look at that in a second after we've finished going through the code. So then we set up the various LoRa channels. So these are the 3 default channels that need to be set at the same frequency. Once again, if you're based in North America or another country outside of the EU, settings might be slightly different for you. In our case, we're using 868 megahertz with slight variation for the receiving device. And then we're specifying the data rate minimum, data rate maximums on that specific device. And once that's been configured, we then go on to joining the network. So this is the activation via over-the-air activation. We then authenticate using the device EUI, the application EUI, and then the application key. We have a timeout set to 0. So basically, if it doesn't connect instantaneously, it continues on the rest of the code. Then we run a little while loop, which says, has our LoPy connected to the gateway? If not, print not yet joined, and then sleep for 2.5 seconds. This just lets us know when we're looking at the terminal to see if the device is actually connected, as opposed to just hanging until, hanging indefinitely. It wouldn't give us any updates or information about whether or not we actually connect to a network. So after that's connected, then we're removing all of the default channels. So this is just a specific to do with how the Nano-Gateway is configured. We're then creating a socket to do the LoRa interaction. We're then setting the socket options. You can find out more about this in documentation. We're then setting the socket to blocking. Sorry, setting the blocking to false. This is so that we can send and receive data without having to hold on the rest of our code. And then we're running a small for loop which just loops through a sending routine which sends the data based upon which number of the loop it's in. So it goes 0, 1, 2, 3, so on till 200. sleeps for 4 seconds, and then waits to receive any data. So this could be like a downlink message back from the gateway, and if it receives anything, prints it out, and then goes back to sleep again. So if you wanted to do your own application, you want to start sending your own data, you can then configure this last part of the code to your specific application, whether that's grabbing data from a sensor, whether that's, there could be like temperature collection, could be the moisture levels in a plant pot's soil, which is what we have in the office right now. It could be a whole range of anything, depending on what your specific use case is. So you'll send your data using s.send, which is the socket connection, and then that goes up over LoRaWAN to the gateway. So this code should now be running on this device. So this is the LoPy we're going to be using as our what's known as a node, and basically we're just sending a loop of various payloads that just contain byte 1, byte 2, byte 3, byte 4 from our for loop. And once we restart that, it should boot into its main.py script, and then we should be able to see some data appearing on the back end, on the TTN console. So I've just plugged this into our USB. You should see the LED start flashing. That's now powered. LED started to flash. Yep. So it's running through its boot.py routine, and then continuing on to main.py, and then making a connection up to our gateway. So if we have now a look at that specific application on TTN, we can see, I believe that it's registered here. Yep. So this device is online, I believe. Maybe it's not this one. Maybe it's another setup with another application, but we'll see in a second. Okay, potentially. So let's just quickly jump back into terminal and see what this one is doing. Okay, so we've unplugged. Oh, this would help as well. We need to plug the gateway back in. So let's plug the gateway back in, and then that should hopefully start receiving our payload data. Maybe that's why we're not receiving anything from the node. Okay, so the gateway's plugged back in again. That should now jumping onto the Wi-Fi, and we'll see that appear again. And then our node should then have something to connect to. So let's just jump into that node's code, or that node's REPL, and see what it's doing. So let's check the gateway's come back online again. Let's see when the gateway was last online. Okay, let's just refresh that, see if it's come through. Yep, so that's the gateway's now online, and now we're going to quickly check. Oh, okay, fantastic. So we've now just seen our LoRa node connect up to the network as well. So that's given us a little message telling us it's connected, and we should now start seeing our data coming through on TTN. So we're looking at this specific device, and we can check out its data, and as we expected, we can see that approximately every 10 seconds it's sending up its data. So fantastic. So this application isn't synced directly to the device. The LoPy that we're transmitting data from is not connected over Wi-Fi, it's not connected over Bluetooth, it's using LoRa to our Nano-Gateway, which is receiving our data and relaying it back to our application. And from here, you can connect it up to whatever else you want to do. So whether that's, oh, sorry, Todd, I missed your question. Let me have a look quickly. The gate EUI, no, the gate EUI doesn't matter. Basically, it's just to link the registered gateway on TTN back to a specific device. So if you had like 3 or 4 different gateways that you were deploying, then you would want to set the gate EUI to that specific gateway that you registered. So if you had like 3 or 4 that you had deployed around a city, for example, and you wanted to know which one was doing which one had failed, for example, you would use your ID to identify which one had gone down. There's no specifically generated MAC being used there. It's a user input string. Back to the application data. Let me know if that answers your question, by the way, Todd. I've got the chat up on the side now, so I should hopefully catch any questions coming through. So we're seeing the payload coming through here, and what we should actually see is that so because we are sending a payload from our device, if we look back at our code again, let's just quickly jump into that. So if we look at our code again, we can see that what we were doing was we were scrolling through between range of 0 up to 200 and creating packet number and then the bytes. If we then go back over to Chrome, you can see that actually, if we look at all of the data, you can see that it's incrementing by 1 every time. So we've got E, D, C, B, A, and it's obviously going +1 through hexadecimal. So this makes sense. You can add your decoding if you want to through, I think it's settings, is it, in application? Maybe it's not settings, maybe it's an overview. I might actually be back into the application. Yeah, so if you go back to your application, you can see a thing called payload functions, not functions. Oh, it's logged me out apparently. So let me log back in a second. Back to applications, and then we can see Pycom Office, payload functions. So what we could do here is, if we wanted to, we could decode our payload upon arrival. We know what we're expecting from what we sent, but if you wanted to make it clearer for when you're doing debugging or checking what was happening, you could do it in here. So this is just a quick JavaScript function for doing the decoding of your payload. And this is obviously down to your specific use case as to what you're doing, but it might make it easier for doing any debugging or checking that the data you're receiving is correct. So yeah, so we've got our data now streaming in from our node to the gateway. We can then do whatever we want with it. So let's have a look at an integration. Let's just create an integration. Let's just do datastore. I don't think I've set this up, but I think we can just quite easily get it running. Yeah, so now we can go to that integration, and we'll have a look at the data that's being stored. So you can then query all of the data that's in here. So if you, for example, you wanted to just do a quick GET request to check where I'm going to go back and grab a key. Where do I get the key from? And in which case we'll look at maybe we'll look at doing an integration application maybe later. It's already starting to run on a little bit, but you can see as we dump in data into this Things Industries data store, you can use then their API for retrieving your data back from there. And this could be actually anything you wanted. It could be a Mongo database if you wanted to. So let's say we wanted to add a HTTP request. We can specify the URL to be a little web server we create that then handles our data, converts it into a document, and then inserts it into like a MongoDB database, or it could be an SQL database, and you set it up to your specific schema. However you want to store your data or handle your data, you can do it from here. So yeah, that generally covers most of the interaction for doing TTN and setting up your Nano-Gateway. And once you've experimented and how to play with the Nano-Gateways, if you want to start doing deployments with larger gateways, the same kind of integration applies. The setup for a fully fledged gateway is a bit different to the Nano-Gateway, but I think TTN has some really good instructions as how to get started with various types of gateways. So yeah, I'll take any quick questions now. Otherwise, if you missed this live stream and you want to catch up, you can jump over to the forums, and under the events category, you can find Alex's Corner Week 3. If you post your questions in there, I'll happily try and answer them for you. I've noticed some people were struggling a little bit with setup. This was, I think, to do with a bug that happened a couple of weeks ago in the firmware that's now, well, it's been gone for about 2 weeks now, but I think some people may have been using old versions of the firmware, so might have been running with that bug before. Basically, the rule with this is if you're running into a bug, check the release logs, see if it's been fixed. If it hasn't, then drop it into the firmware category on the forum, and make sure you're running the latest version of the device firmware. Otherwise, you could be running into old bugs that have since been eradicated. So yeah, I've got the chat open. If you want to drop me any last questions before we get going, I'll wait a couple of minutes. Otherwise, yeah, good luck with your gateways, and I'm excited to see what kind of projects you're building. As a quick reminder, we do also have a Hackster.io challenge on at the moment. So if you create a Hackster.io tutorial, workshop, project, whatever you can think of, publish it to the Pycom group, and let us know on the forums by sharing it. We'll have a nice prize for the top submission. Todd's asking, what do we have planned for week 4? So week 4, I'm not quite sure yet what we want to do. I'm happy to take suggestions. I was thinking about maybe taking a different group. So we've done Sigfox and LoRa. Sigfox is week 1. I might do a recap of that because that didn't go onto YouTube and it would be useful to have that up. Maybe it might be interesting to do some MQTT over Wi-Fi, or maybe looking at doing some actual hardware interactions, maybe doing some sensor stuff. We could do an application where we do MQTT plus a sensor, sending the data up to maybe an MQTT broker, retrieving it, and maybe some other integrations. I'm happy to take suggestions, so drop your thoughts and comments into the forums or in the chat now if you have any ideas, Todd. And yeah, so week 4 will be in 2 weeks' time. So let me grab my calendar and have a quick check date for that. That will be the 13th of April. Right before the British Bank Holiday weekend. So a great time to start having a go at a new project. Yeah, I'm thinking maybe doing something with MQTT. If the community is after something else specific, do let me know, and we'll cater for what people are working on and if they're having any issues and problems with some of the code they've written. So thanks for joining in, and if you do have any questions, drop them in the forum. Otherwise, see you in 2 weeks. Goodbye.